Welcome everybody. It's Ramchandra from Gate Maths Concepts MRCL channel. Till now, 5 lectures had been delivered and published in YouTube for the benefit of GATE 2025 aspirants in the subject Engineering Mathematics. The first topic, Linear Algebra, was taken, and under Linear Algebra, with the geometrical interpretations, we have come to the stage of understanding the characteristic equation and understanding the rank of a matrix. Now, we will further continue on characteristic equation, simultaneous equations and rank of a matrix in this lecture also, because it is a lengthy topic, and I request everybody to view the video till the end and also understand the concepts. Kindly review my lectures. Already 5 lectures have been published. Kindly comment and review my lectures honestly so that I can further improve my lectures in the next ongoing typical subjects like calculus, Fourier series, differential calculus, integral calculus, differential equations. Calculus is the subject which I am going to take after linear algebra. Now, in linear algebra, we will be continuing with our discussion on simultaneous equations and rank of a matrix, and also characteristic equation, inverse of a matrix and its usefulness. Characteristic equation. Let's go. Move forward from 2 by 2 matrix to 3 by 3 matrix. I will give a very good example now. We will proceed for further understanding of the characteristic equation and its further meaning, and also I will give a glimpse of improper integrals which I am going to take up as my first class in calculus after couple of linear algebra lectures. Improper integrals. I will give a glimpse of improper integrals in this lecture. So you will understand how improper integrals problems can be tackled in GATE examination in calculus. It's a very important topic. Don't miss out. Integral calculus or a calculus. Improper integrals are the most important, and maximum questions will be asked from calculus on this only. Improper integrals are linked to series and sequence, series convergence, series divergence, improper integrals, Riemann integrals. These are very, very useful, not only from the GATE point of view, for your engineering applications also. These are very important. Now let us concentrate on the present topic. Present topic is lecture number 6, Linear Algebra, lecture number 6. Now in the last class we have discussed about characteristic equation. Now, instead of theory, I want to go ahead with a very good example. I have taken out of my experience only, not from any book. Please do it. Please do this problem along with me. Try to understand the process. Let us involve everything of linear algebra in this. Let us try to involve. It's a 3 by 3 matrix, a good problem. Let us see. The question is, it will be a lengthy question, but it involves everything, almost everything. If you do this problem, then ultimately if we can understand, if we spend a couple of videos on this also, lectures on this also, it is worth. If you understand one problem, the whole concepts will be understood and you will not be hesitant to do any type of questions, and 2 by 2 matrix will be a cakewalk for you once you do the 3 by 3 matrix problems. Now, let us take the problem as there is a set of simultaneous equations 3x plus 7y plus 9z that is equal to 21, x plus 5y minus 8z is equal to 43, x minus 7y plus 3z is equal to 46. This is my equation. These are my simultaneous equations involving three variables. What we have to find? Let's involve everything. Find xyz, that is characteristic equation, of parent matrix involving xyz, matrix of xyz variables. Then use the row elementary operations, find the inverse of the matrix, then find the inverse of the matrix from characteristic equation, find eigenvalues, eigenvectors for the same problem. Find the determinant, find the rank of the matrix. Let us see to what extent we can proceed today. Then, if everything could not be completed in this lecture, in the next lecture, we will try to solve the remaining portion of the problem. Now, what is the equation? 3x plus 7y plus 9z is equal to 21, x plus 5y minus 8z is equal to 43, x minus 7y plus 3z is equal to 46. Can we write those equations in this matrix form like this? 3, 7, 9, x, 1, 5, minus 8, 1, minus 7, 3 into x, y, z is equal to 21, 43, 46. From this, now I got an idea. Why shouldn't we add another question to this problem? What is the value of minus a cube plus 11a square plus 33a. With the concepts whatever we have learned till now, from that we can solve each and every part of this question. First, we have written whatever simultaneous equations given, we have written in matrix form. This can be written as matrix A, matrix X is equal to matrix sum D. This is what is the simplified final matrix form of this simultaneous equations system. Now, what is A? Matrix A is equal to 3, 7, 9, 1, 5, minus 8, 1, minus 7, 3. Then, to find out the value of minus a cube plus 11a square plus 33a, what we require? We have to see whether the characteristic equation has any relation with this whatever is asked in the examination. It's not asked in the examination. This type of question can come in the examination. That's what I have told you in the last lecture. Now, if you are going to do minus a cube plus 11a square plus 33a in a traditional form, it may require lot of time. There can be little bit of numerical errors. There can be problems. Then in that case, what to do? This can, let us assume that this is the representation of some characteristic equation of this matrix of A. Now let us see whether it is correct or not, our assumption. Now, what is the characteristic equation? Characteristic equation is equal to determinant of A minus I lambda is equal to 0. It is the characteristic equation of the above matrix. Now, what is the value of A minus I lambda determinant? The determinant of A minus I lambda will be determinant of 3 minus lambda 7 9 1 5 minus lambda minus 8 1 minus 7 3 minus lambda. This is the determinant, that is equal to 0. That is the characteristic equation. 3 minus lambda 7 9 1 5 minus lambda minus 8 1 minus 7 3 minus lambda. Now let us expand this determinant. When we expand the determinant, it will be 3 minus lambda into 5 minus lambda into 3 minus lambda minus 8 into minus 7. This is one part. Minus 1 into 7 into 3 minus lambda minus 7 into 9 plus 1 into 7 into minus 8 minus 9 into 5 minus lambda. Why I have chosen this form? Because the first column elements, if you observe, In the second row and third row in the first column, they are unit. So that it will be very easy to have the multiplication. As instead of making them 0, I have taken the values straight away so that it can reduce my burden of calculation as they are unit. Now, let us go for further simplification. What it will be? 3 minus lambda into 15 minus 8 lambda plus lambda square minus 56 minus 1 into 21 minus 7 lambda plus 63 plus 1 into minus 56 minus 45 plus 9 lambda, that is equal to 0, which implies 3 minus lambda into 15 minus 56 is minus 41, lambda square minus 8 lambda minus 41. This, when we expand these two, plus 21 plus 63, 84, 84 minus 1 minus 84, minus 1 into minus 7 is plus 7 lambda. This will be 56 plus 45, 101. 101 into plus 1 minus 101 into plus 1 is minus 101. Plus 1 into 9 lambda is plus 9 lambda, that is equal to 0. Let us further expand. It becomes 3 lambda square minus 24 lambda minus 123 minus lambda cube plus 8 lambda square plus 41 lambda minus 185 plus 16 lambda is equal to 0. That means minus lambda cube plus 11 lambda square minus 24 plus 41 is plus 17, 17 plus 16, 33 plus 33 lambda minus 123 minus 185 is minus 308 is equal to 0. This is the characteristic equation. Now, from this we get minus lambda cube plus lambda square plus 33 lambda is equal to 308, which means if we replace lambda with A, matrix A, the final result will be minus A cube plus 11 into A square plus 33A is equal to 308I. If you see the question, we have asked what is the value of minus A cube plus 11A square plus 33A. This is nothing but 308I. This is equal to 308 0 0 0 308 0 0 0 308. Minus A cube plus 11A square plus 33A is equal to 308I. This is the answer. Characteristic equation is this. This is the answer for whatever that is given. And what will be the inverse? How to find out the inverse? In that case, we can say minus a square plus 11a plus 33i is equal to 308a inverse, which implies a inverse is equal to 1 by 308 into minus a square plus 11a plus 33i. To get the value of a square is very easy. To get the value of a already given and I is known to you. Then with this you can find a inverse very easily with this rule. You take it as a homework and complete the solution for a inverse and compare this value with value obtained from elementary row operations. I will just give a recap of how to find the A inverse with elementary operations. What you have to do? You have to write A and I as a bigger matrix together. You have to write. That will be, what is A? Three, 7, 9. 1, 5 minus 8. 1 minus 7, 3. And besides that, you have to write the unit matrix 1 0 0 0 1 0 0 0 1. Conduct the elementary row operations and ensure that A will become in this form and this will come in another form, that is A inverse. In this way, you take it as a homework. I had already done for one example in the previous class. I don't want to waste my time again doing the same numericals. Please do it on your own and find out A inverse from elementary row operations with above concept. Now, compare it with the previous answer. You have got A inverse with you and you have got A with you and you have to find out the XYZ matrix. What is XYZ matrix? From this, for solving the simultaneous equations, you have got A, you are not aware of X, that is equal to D, which implies X is equal to A inverse B, or we can say A inverse D. Sorry, let us say we will call it as A inverse D. From this, we can solve the simultaneous equation. And the behavior of the simultaneous equation, infinite solutions, which I had already discussed in the previous class. Now, how to find the rank? Rank of the matrix is obtained from the elementary row operations. Shall we go for it? Yeah, we'll find out the rank. That's very important. 3, 7, 9, 1, 5 minus 8, 3, 7, 9, 1, 5 minus 8, 1, 5 minus 8, 1 minus 7, 3. This is the matrix, if I am right. Now, for finding the rank of a matrix, we have to make maximum number of elements to be 0. Let us try. And do something and check for the rank of the matrix. For the rank of the matrix, as I told you, let us try to induce the system of making it either a triangle matrix or a diagonal matrix, and then try to make maximum zeros possible. Let us go for it. What is the first step? For making this matrix into triangular or a diagonal matrix, the first column, second element and third element to be made 0. How to make it? We have to do the elementary row operation. R2 minus 1 by 3 R1. Second is R3 minus 1 by 3 R1. If we perform these two operations, what will be the result? 3, 0, 0, R2 minus 1 by 3 R1. R2 is 5. This will be same. R2 will be 5. 5 minus 7 by 3. Minus 8 minus 9 by 3. Here minus 7 minus 7 by 3. 3 minus 9 by 3. This becomes, this will be 3, 7, 9, 0, 0, 7, 5 minus 7 by 3. 5 minus 7 by 3 means 15, 15 minus 7, 8 by 3. Minus 8 minus 9 by 3 is minus 11, because 9 by 3 is 3. Minus 7 minus 7 by 3, 21, minus 28 by 3. Then 3 minus 9 by 3, that is 0. Now next what we have to do? We have to make operate with the second row, and to see that in the second column, third row element is made 0. For that what we have to do? R1 will remain same, R2 will remain same, R3 will only change. What we have to do? R3 minus R3 plus, let us say, because it is minus 28 by 3, that is 8 by 3. That means when I multiply the R2 second element with 28 by 8, I will get 28 by 3. R3 plus 28 by 8 into R2. Let us do this operation. What happens? Let us see. 3, 0, 0. These will not change because 0 multiplied with any number will yield only 0. Then first row is not affected. Second row is not affected. Third row, 28 into 8, 28 into 28 by 8 into 8 by 3. That is plus 28 by 3. When I add to minus 28 by 3, that will become 0. Then here, minus 11 into 28 by 8. Which is equal to 300, 0, 7, 8 by 3, 9, minus 11. This is 28 by 8 is nothing but 7 by 2. 7 by 2 into 11 minus 77 by 2. Is it correct? 4 7 28, 7, 7, 77, 3 minus 9 by 3 minus 3, 0. This minus 11 into 28 by 8. Because R3 is 0. This is added. Now, if you try any other operation, the value of this is there, this value and this value. The value of this, they will either add to the existing zeros. You cannot make any other by using any other value, by using any other elementary operation, row operation. You cannot make further zeros in the matrix. When you cannot make any further zeros with any operation, then this matrix is the last matrix which is available after doing all elementary operations. This is having real values or whatever may be complex values also, some value other than 0 in 3 rows. That means the rank is equal to 3. You cannot further reduce this matrix. Very simply, we got the rank of the matrix, and A inverse you can get. With that X you can find out. Rank of the matrix is found out, and we cannot go further reducing. Now, shall we go a step ahead? What is the trace of this matrix? Even though I didn't ask in the main question, I just want to make you aware. What is the trace of this matrix? Trace of this matrix will be sum of the diagonal elements. That is equal to 3 plus 5 plus 3. That is equal to 11. Trace of the matrix is 11. Then can you tell me, what is the determinant of this matrix? Please, for God's sake, don't compare your row reduced matrix with the original matrix and say that with row reduced matrix multiplication I will take, and I will take that as a product of the eigenvalues and I will equate it to determinant. No. The row reduced matrix is entirely different from the original matrix given. And I have already told you how to find out the determinant of a 3 by 3 matrix easily. From that, you find out the determinant. Determinant value is minus 308. If you remember, few minutes back, we have discussed about 308 value in the characteristic equation. From characteristic equation, we got this determinant. Now determinant is known, trace of the matrix is known, characteristic equation is known. Now the value of x and y, x, y and z can be calculated easily. The rank of the matrix is known, and the final one is the value of minus a cube plus 11a square plus 33a is equal to 308i. That also we came to know. We almost had solved all the parts of this problem. Now, if you follow this, now eigenvalues and eigenvectors. Eigenvalues you can very easily find out from this equation. You can solve this and you can find. And if you don't want to go for it, I have already told you the simplest method about finding the eigenvalues. That method, this is what you call this particular equation. This equation, you do row elementary operations and find eigenvalues. You make these two values 0 and this value as 0, then you will get some combination. From that you can find the eigenvalues. Once eigenvalues are there, you can find the eigenvectors, which I have already explained to you. And please solve this problem in full. What I suggest, solve this problem in full. And compare your values. The eigenvalues, I will give the answers. Please solve eigenvalues. Lambda 1 is equal to 11.5. These are approximate values. Lambda 2 is equal to minus 5.5. Lambda 3 is equal to 4.9. I have taken only one digit values. Now, inverse is, I will give the answer. Please get these answers on your own. One by 308, 41, 11, 12, 84, 84, 0, minus 28. These are all done by me. Please do on your own. It is not that I do here. I have explained the procedure. Please do on your own. This is the inverse of the matrix. Then eigenvectors. Point 0.06 minus 1.21, 1 minus 1.8, 0.9, 1, 7.9. I have taken values up to single digit. 0.8, 1. You notice the final value is always 1. We kept for eigenvalues, eigenvectors. If it is a 2 by 2 matrix, we will keep the y coordinate as 1, y coordinate value. If it is a 3 by 3 matrix, we will keep z coordinate as z coefficient as 1 coefficient. This procedure I had already explained in the previous lectures. From this you do it. Eigenvectors, inverse is their value for you, eigenvalues are there, eigenvectors are there, inverse is there, x and y and z values are there with you. Traces you have already calculated, and determinant is also there with you. Please go ahead and solve this problem. And now the next thing comes, condition number. Condition number is 13.9. It's a good number. It's not infinity. That means determinant is not 0. And it's a very good simultaneous equation system. And condition number, the definition and how to find out the condition number, I had already explained in the previous classes. Please go through. Now, you can read your textbook, standard textbook, like higher engineering mathematics by Gravel, for definitions being used in matrices and determinants. Higher engineering mathematics by B.S. Gravel, sir. You please read that book and understand the definitions, and everything is explained very well in that book. Now, next, I want to talk about little bit of improper integrals, which we come across in our day-to-day calculus problems and also physical interpretations of the systems. Now, what is integration? Integration is nothing but, as a definition, it is summation. Integration is nothing but summation. What is summation? It is nothing but adding things. For example, I have an xy plane like this, and I have a trace of a particle P. The trace of a particle is like this. These are the coordinates x1, y1, and in between there are x2, y2, x3, y3, x4, y4, and I have another. This is P1, this is Pn, xn, yn. Now, the area under the curve on this xy plane is called the integration. The area under the curve. That is adding things like this. We will cut into small slices. We add. Now, I will give a typical improper integral. Everything is not proper. The behavior of the curve may not be proper. The behavior curve can be erratic. On the conditions under which it is being operated, it can be erratic. What to do? In that case, when the regular integral, we are unable to get the answer. With the regular integration process, if we are unable to get the answer, then we have to go for other procedures. With this basics, conceptual processes we have to go for. While going for the conceptual processes, all these things will be defined, explained by me very clearly to you, so that you will not have any problem while addressing the conceptual problems. Now, improper integral. Our heading will be improper integrals. I know it is an advanced topic. Without discussing proper integrals and differentiation, I am jumping onto improper integrals. Definitely I know it's a tough topic to understand, but however, it is required. I want to take the topics parallel so that you will have a feel of belonging to other topics of the mathematics also. Once you master your improper integrals, then your regular integrals, differentiation, differential equations will be very easy to understand. Now I will give one problem to you. You try to solve it. Please try to solve it. Please try to solve it on your own. This problem, integral x by log x dx. Don't worry about the base of the log. We'll take base as e, natural logarithm. We can even write it as integral ln x. Now integral x by log x dx or integral x by ln x dx, use this concept. Integral is a summation, and try to find what is the graph of this x by ln x. Draw the graph, try to draw. Is it showing any erratic behavior? Is it a regular graph? Does it have any boundaries where it is not defined? Undefined boundaries? Undefined character? Undefined behavior? You try to find. First is draw x by ln x. Then find areas under the curve. Then do the summation and find the integral. That's what is the simple procedure. Can we draw this x by ln x? Please try. People say it is one of the toughest questions of improper integrals. Summing up of x by log x dx, or integration of x by log x dx, or integration of x by ln x dx. Different people have different opinions on this, and I will explain it after completing my linear algebra classes. Maybe in the next class again I will give some more hint about how to do improper integrals in GATE examination. You please take this as a challenge, do some challenging problems and solve them. Best of luck. It's Ramchandra again. Best of luck to all of you for the GATE 2025 examination, and try to be smart, try to do mathematics to the maximum possible extent with zero errors, and try to get the maximum possible marks in engineering mathematics. Once again, best of luck to everybody. Not only for GATE aspirants, for UPSC aspirants, even for IIT JEE advanced courses, this mathematics course will be very useful. And not only examination aspirants, even for the mathematics enthusiasts, I feel my lectures will be very interesting and very useful to them. Try to solve this improper integral or an integral, something which has some value addition to your knowledge. Integral of x by log x or integral of x by ln x dx. Looks simple, but it's not so simple. Best of luck. Thanks a lot for listening to me.